So good morning, we're going to get started. Welcome to this session on the newly announced AWS Transit Gateway. Hope you're all pretty excited about that, and we certainly are to get it out there. My name is Steve Seymour. I'm a Principal Solutions Architect. I'm one of our networking specialists. I work with our customers across Europe, Middle East, and Africa, and have deep dive conversations around networking. So this is a really cool topic to be up here talking about. This is Thomas Spenley. He's the General Manager for Transit Gateway and for our VPN service. And let's just get this out of the way right now. The right word is route, okay? We're not going to be talking about routing. But actually, I guess out of respect for my co-presenter here, maybe I'll slip the occasional route into the discussion that we're going to be having here. We'll see how I get on with that. It feels a bit alien. So some of you might have already seen some of these new icons in some of the other sessions. And I think this is pretty self-explanatory here. We've got a cloud environment. We want to be able to route things within it. That's what Transit Gateway is all about. So it's a new service that enables you to interconnect thousands of VPCs and your on-premises networks. And that's what we're going to be spending the next hour talking about in a bit more detail.
Thanks, Steve. So what is Transit Gateway? So let's be clear, it's not a physical device. It's a fully managed, fully distributed AWS service. And when we started the journey with Transit Gateway, we wanted to make sure that we could connect VPCs together and help do that for customers simply. And so, as you would expect, Transit Gateway has the capabilities to allow you to connect thousands of VPCs together at scale and across accounts. And so, whether you start your AWS journey with 2 VPCs or if you have thousands of VPCs, Transit Gateway allows you to make simple and complex routing decisions based on your requirements. One of the other things that we heard from our customers is application teams can move very quickly by adding new VPCs, while networking teams would move a little slowly trying to connect their on-premise networks to AWS. And so with Transit Gateway, Freudian slip. So with Transit Gateway, you're able to share that on-premise connectivity across all your VPCs, allowing your teams to be agile to meet business requirements. And then lastly, we wanted to be able to provide our customers with unique advanced routing features that allows you to build flexible network topologies. And so we created the ability to have multiple route tables. And with these route tables, you'll hear this concept of routing domains. And Steve's going to go into that a little bit more in this session. But with routing domains, you can actually create very unique routing topologies and allow you to isolate or create an any-to-anywhere network. Thank you.
Okay, so taking those 3 concepts we've got, that interconnecting VPCs, that consolidating edge connectivity, and that flexibility with the routing domains, let's just dive into what that might actually look like. So taking our example here, we've got a typical customer scenario. We've got 4 VPCs here. If you wanted to connect those together before yesterday, you would have done that using VPC peering. So you would create a VPC peering connection between each of the VPCs. In this case, we actually want all of the VPCs to communicate with each other. Perhaps these are all development environments, maybe some dependencies between them. So we're going to have to create a full mesh of VPC peering connections. So just with those 4 VPCs, we've already got 6 VPC peering connections in place. Now, what you can see here is that if we drop the new Transit Gateway into this topology, what we actually have are just 4 simple attachments to that Transit Gateway. Let's go back to our scenario again with our 4 VPCs and with our peering connections in place, and now add the fact that these development teams want to be able to connect back to our on-premises network. So that's fine. We're going to have a customer gateway, the end of a VPN connection that exists within a customer's network, and we're now going to build VPN connections out to each of those VPCs. And for those of you familiar with VPNs, you're aware that those VPN connections terminate on the virtual private gateway for each VPC. Each of those connections is actually 2 tunnels for resilience. We have 2 endpoints on the AWS side for each of those VPN connections. So this is what it would look like in a world before Transit Gateway. But now that we have Transit Gateway in the mix, it's as simple as creating a single VPN connection to the Transit Gateway itself. It still consists of 2 tunnels. It's still resilient on the AWS side. So this now vastly simplifies your setup. Now, let's go back to that scenario. We've got our VPN connections in place. We've said that they're highly available on the AWS side. We have 2 endpoints for you to connect to. But obviously, our recommendation to you is that you have a highly available pair of endpoints on your end of the connection. So what that means is there's going to be 2 customer gateways within your infrastructure, and we're now going to create additional VPN connections from each VPC back to that pair of customer gateway devices. Well, of course, you can see where this is going. When we put Transit Gateway into the mix, it's as simple as creating 2 VPN connections, a total of 4 tunnels, and you have resilient connectivity from an on-premises network to all 4 of our VPCs.
Thanks, Steve. So obviously, I think you get the concepts at a high level. Steve did a good job of presenting it at a 10,000-foot view. So let's take it down to a 1,000-foot view and see what it looks like to actually create the components of a transit gateway. So let's take this scenario where you have a development environment where you have 4 VPCs. Each of those VPCs need to communicate with each other. And you also have the additional requirement to connect back to on-premise resources using a VPN connection. So you might be doing that because you're accessing a code repo or a user needs to be able to test from on-prem. And so one of the things that we want to make sure that we're able to do here is we want to allow our development teams to be able to add new VPCs or destroy VPCs on the fly without having to worry about creating new VPN connections or reconfiguring the on-premise router. So the first step here, let's go ahead and create 4 VPCs in our development account. Let's put them in within the 10/8 range. So we've got our 10.1, 10.2, 10.3, 10.4 VPCs. And then each of these VPCs has a subnet in 2 availability zones. First, we'll go off and create in our console, our VPC console, a transit gateway. And all you need to provide is just a name. And so here, we're just going to use the defaults for the rest of the parameters. When the transit gateway gets created, you'll see here that the state becomes available for use. Now, one of the things to call out here is a transit gateway is a regional object. It's highly available and highly scalable. So how did we do that? So if you were here at reInvent last year and you happened to catch our talk or discussion around hyperplane technology that we discussed, you'll know that it's highly scalable and highly available, and a transit gateway is built on that building block. So we've created our transit gateway in the console. The next step is to attach our VPCs to the transit gateway. And so this is actually pretty easy. All you do is select the transit gateway that you want to use, select the attachment type, which is a VPC, and then just provide the subnet of the availability zones that your VPC is in. Now, again, just remember, the transit gateway is a regional object. It has zonal attachments, and you only need to provide 1 subnet for each availability zone that you're in that VPC. We repeat that process 3 times. Very simple, very easy for each of the other VPCs. So now we have a transit gateway. We have attachments. We've attached our VPCs to the transit gateway. And you see here that each of the attachments are available, and all of the default parameters are applied in the screen below. Now we got to make sure that basically we have a route from the transit gateway back to our VPCs. And so looking at the transit gateway route table, you see here the list of all the CIDRs of our VPCs. You also see the attachment IDs. So this helps confirm that we have a route basically from our transit VPC or transit gateway to our VPCs. Okay? Now we also have to think about the return path. So how do we know that we can get traffic from our VPCs to the transit gateway? So in our VPC route table, we need to put a 10/8 destination address with a target of transit gateway in the target field. And that's it. So how do we know it's working? So we created the transit gateway, we attached the VPCs, we updated the routes from the transit gateway to the VPCs and the VPC route table back to the transit gateway. So here we set up basically 4 EC2 instances in each of the VPCs in the .50 subnet, and logged into the EC2 instance in the 10.1 VPC, pinged the other 3 VPCs or 3 other EC2 instances, and you see they all responded. And so what you're seeing here is the actual screenshots and an actual deployment, and we just created an any-to-anywhere connectivity between these VPCs. That's it. Now, if you remember the original scenario, we needed to be able to connect back to on-premise through a VPN connection. So it's as simple as going back to the attachment, selecting transit gateway, selecting VPN, And here, you can either use an existing customer gateway or create a new one. And as you know, the customer gateway has the IP address as well as the ASN number for BGP. We switch over to the VPN console, and you download the VPN configs template, and you just update that to your customer gateway router. And you only need to do this one time. And so once your VPN tunnels come up, the BGP sessions are established, you'll see here that the 10.99 prefix in the route table via the VPN connection. So now you have a path back. And again, how do we know it's working? So right here, we jump back on our EC2 instance in our 10.1 VPC. We ping back our customer gateway, and we see that it's reachable. No other configuration is required. So from the on-premise side, from our customer gateway, how do we know we have connectivity? So if we look at our BGP route table, what we see here is the CIDRs of all the attached VPCs available, and we see two paths, each for the two tunnels that were created automatically with our AWS VPN. And then lastly, obviously, you could do all of this through the AWS console. You can do this through the AWS command line. You could do it through a direct API call. And for those customers who use VPN today, you see here that the only change to what you do today is you can either pass a parameter of transit gateway or pass a parameter of virtual private gateway.
Cool. So you've seen the basic concepts here and how it works. But I wanted to go into a little bit more detail here. So first of all, there are two really important key concepts for transit gateway. The first one are attachments. So we've talked about attaching VPCs. We're going to dive into that in a little bit more detail. The second really important concept for a transit gateway is route tables. And within route tables, we have two topics to discuss around association and propagation. So let's have a look at each of those concepts in turn. So this is the new icon for the transit gateway. You're going to be seeing a lot of this. And this is where we're starting from. We create our transit gateway first. You saw that example in the console. And the next thing we did was to attach some VPCs to that transit gateway. So what you're seeing here are two of the VPCs from the previous example, 10.1 and 10.2. They're the ones we're going to be working with. And we're going to attach those to the transit gateway. So in this case, I've called the two attachments attachment red and attachment blue. Obviously, these show up as identifiers in the console. But these are our two attachments. Now, once we attach them to our transit gateway, remember there is a route table involved here. And that route table exists inside the transit gateway itself. Now, when you attach a VPC to the transit gateway, you actually have to identify a route table to associate with. Now, when we created the transit gateway earlier, we left all of the defaults in place. So what that means is if we look back in the console, we can see that there is a default route table for association, and the association is enabled, and then we also have propagation enabled to that same route table. So what does that actually mean? Well, here we are. We've got our attachments associated with this single route table that we have inside the transit gateway. And what that means is when traffic comes in from that particular VPC to the transit gateway, this route table is the list of instructions that are going to be followed. It identifies the next hop and where traffic should flow to. But actually, we don't have any entries inside that route table at the moment. So if a packet did come in from one of those VPCs, perhaps from the 10.1 VPC, and it's trying to get to 10.2, it would come into the associated route table, but there's no entries in there, so it would effectively get dropped. What we have here is the concept of propagation. So propagation is an automatic way of taking the CIDR range for a particular attachment, in this case a VPC, and propagating it into the route table. So in this case, we've got 10.1 being propagated over that red attachment, and 10.2 being propagated over the blue attachment. So now we have a route table that is actually useful. It has entries in it that tell us how to get somewhere. So that's it. That's our route table complete. That's effectively what a default deployment actually looks like. But we talked about needing to configure the VPC side of things as well. So let's just go to the VPCs. Remember, we do need to add an entry in there that says, if I have traffic that is trying to get to, in this case, 10/8, then let's put an entry in the route table, and we just specify the next hop as the TGW identifier. So this is the same as you're probably used to creating, a default route to the internet gateway, perhaps, or routes to a VGW for on-premises connectivity in the past. It's exactly the same concept. So we put those entries into the route table. That's the default. So this is the situation we actually created earlier. And the screenshots you saw, those are real screenshots of exactly all of the steps involved in getting to the point that we showed you. This is the result we had here. We had a VPN connection. Obviously, we had 4 VPCs. In this example, we're showing 2 of them. We were automatically associating all of those attachments with the same route table, and we were automatically propagating all of the routes into that same single route table. So that's the default. That's how easy it is to connect all of these things together. But I think all of you would like to move a little bit beyond those basics, and let's look at some of the other capabilities here. So here's our scenario. What if we want to have more than one route table inside our transit gateway? So we could have 2. What about having 3? Well, we had 3 attachments that we've been talking about here. We had 2 VPCs, and we had a VPN. So let's actually create a route table for each one of those attachments. It's associated with that route table. And now we need to consider what's actually going to end up inside these route tables. And that's the topic of propagation that I mentioned. Now, this is the overall concept of creating routing domains. So you can create a route table here to decide where traffic flows in different situations. So we are creating these separate domains of behavior, and that's what we have inside the transit gateway. So our first step is we're going to propagate 10.1, but instead of letting the defaults happen, we've actually specifically chosen here that we're going to propagate 10.1 into the route table that is being used by the VPN attachment. We're going to do exactly the same with 10.2. So now we know that if traffic comes in from the VPN, it knows how to get to those 2 VPCs. OK, well, what about traffic flowing the other way, the traffic that is going to be coming perhaps from one of those VPCs? It needs to know how to get to a VPN. So again, we can choose to propagate the routes from the VPN attachment into the 2 route tables at the top here. So this is now what we have configured here. This is what we're going to be seeing for our traffic flow. Now, remember, you could use that propagate option. It makes things nice and easy. It means as you update, say, the CIDR ranges for your VPC, or you change your BGP announcements from an on-premises environment, it automatically will update in these route tables now that we've turned on propagation. But these are just route tables, so you can put static entries in there if you like. You can put a static entry in that specifies an attachment as the next hop. That's all that propagation is doing, but it's doing it automatically for you. So just consider that you have options in the future to put static entries in, and that might be quite useful. So let's just recap what route tables give you the ability to do here. First of all, a route table is all about identifying the next hop for traffic. You can put those static entries in if you like. You can even create what we call black hole entries. So what that means is if you have traffic destined to a particular IP address, but you actually don't want it to flow for a particular reason, you can actually just put a black hole entry straight into the route table, and that packet will get dropped. It's important to remember when you have static entries and black hole entries in your route table that they take precedence over anything that is coming in dynamically, i.e. anything that's coming via that propagation process I talked about. So effectively, the static and the black hole entries override anything that's coming via a propagated entry. You've seen that by default, when you create a transit gateway, it has one route table that's being created. All the attachments you then make to this transit gateway are automatically associated to that particular route table. Again, also by default, propagation is turned on. We've done this so that it makes it really simple for you to get started, but it means that everything can route to everything. The next step beyond that was that we said we could have multiple route tables inside our transit gateway. It's important to remember an attachment can only be associated with one route table. Remember, it's the set of instructions that are followed for traffic flowing into the transit gateway. But an attachment can propagate its route to any number of the route tables that you want. So this gives you the idea that with a bit of extra configuration and a bit of architecture and thinking around this, you can actually build some really quite interesting setups here and have full control of the routing within the transit gateway itself. Now, the concept of routing here, you might be struggling a little bit just to think about how these packets are flowing around. Basically, it's all about thinking about what is the next hop on a path. You know, if you were driving somewhere, it's the decision you would make at a particular turning or a particular junction. And I find when looking at things like this, it's actually really helpful to visualize that and actually visualize it from both perspectives because traffic needs to flow in both directions. So let's go back to our setup here. We're going to introduce Dave into the equation here. Dave is in our on-premises environment. and he has a packet that he wants to get to 10.1.0.50. So it's in the 10.1 VPC. Now, the first thing that Dave is going to do is look at the on-premises environment and look, do I have a route to get to 10.1? Now, we know that 10.1 is going to be advertised from the transit gateway over the VPN connection to that on-premises environment. And you can see it there. It's being received via BGP. So Dave is going to follow that path into the transit gateway. Now that he's inside the transit gateway, we're going to look at the route table that is associated with that VPN attachment. In that route table, remember we've got the entry that we propagated to it earlier. So we've got 10.1, and we know that to get to 10.1, we go via attachment red. So that's fine. Dave now follows that step via attachment red and is now inside our 10.1 VPC. So life is good. But now he realizes he actually needs to go back home again. So how does he do that? He's going to look for an entry in the local VPC route tables to get back to 10.99, the on-premises environment. Where is that entry? Well, remember we created it in the route tables inside the VPC. And we have a next hop here that is the transit gateway. So great, Dave follows that back. We have the route table here associated with the red attachment. Dave looks at that entry, sees an entry there that says 10.99. That's the on-premises environment I'm trying to get to. Remember, that was propagated earlier from the VPN attachment. So Dave follows that. We come down to the VPN. Needs to look, where do I go next? Well, we're receiving an announcement of the on-premises environment, the 10.99, coming over that BGP session. So great, Dave is back home, and it's really quite easy when you just follow those steps. So the idea of this is just to give you a way of thinking about this, and as you build some creative route tables here and decide how you want your traffic to flow, that's the kind of process I go through when I'm thinking about how is this traffic going to get both to and from two attachments on a particular transit gateway. So you've seen a couple of different transit gateway architectures here. You've seen any-to-any, which is the default, very easy and quick to get started. You've also seen a scenario here where we've shared some edge connectivity. We've got that VPN connection giving you access to two VPCs. But what about if you wanted to have a slightly different setup here? Perhaps these two VPCs actually should never be able to talk to each other, which was, remember, our default situation. But they both want to share that connectivity back to the on-premises environment. You don't want to go back and create multiple VPNs just to isolate them. So could we perhaps do that with Transit Gateway? And the answer is, of course, yes. And actually, it's what we had in place a moment ago. So if we put Dave back into his VPC here at 10.1, and we say, I want to get to 10.2, the other VPC. So remember, the first step here is to look at the route table inside the VPC. We're going to follow that, and we're going to end up at the Transit Gateway. Now, the route table that is associated with this attachment doesn't have an entry in it for 10.2. We didn't propagate from the 10.2 attachment into this particular route table. So at this point, there is nowhere for Dave to go. The packet drops there, we stop. So in that scenario we built, we actually already have isolation between these two VPCs, but the ability to share that VPN connection back to the on-premises environment. Now, you can see that this is just the start of some really quite interesting architecture possibilities here with Transit Gateway. I've put a few examples up on the screen here. You can actually even have multiple transit gateways attached to a VPC. So you can see how this would become really quite interesting. There is a session on Thursday, Nick Matthews is presenting that, on transit gateway architectures. So if you're really interested in some of these design patterns, some of the ideas that we have here and some of the things that we've seen customers want to use Transit Gateway for, I'd really suggest you go along to Nick's session and see what he's got to share there. Now, I mentioned the other concept here of VPC attachments, but we haven't looked at it from the VPC side of things. So first of all, let's just remind ourselves, Transit Gateway is this regional object. It is something that is a single target for those route tables inside your VPC. But we said you needed to identify which availability zones you were using, and you had to choose just one subnet in each of those availability zones for this to attach to your VPC. One of the options you have here is to use some existing subnets. That's absolutely fine. But if you're building a new environment here, or you have spare address space within your VPC, my suggestion would actually be that you create new subnets purely for this attachment. And you'll see why in a moment. It gives you some really interesting options of how you route traffic inside your VPC. But you can use those existing ones if you need to. So here's what is probably a pretty familiar architecture for you. We've got our VPC. We've got some public subnets, one in each availability zone. We've got 3 availability zones here. There's a route table that is associated with those particular subnets. And the default route is via the internet gateway. We've then got some private subnets. There's a route table that we're using for those private subnets. And actually, the entries in that route table are going to be a little bit different. And we'll look at that in a moment. I've then created 3 more subnets that I'm going to use for connectivity. These are the ones that I'm going to be using with the transit gateway itself. So when I attach the transit gateway, what you'll actually see in your VPC is 3 network interfaces get created. And you can see these if you go and look in the network interfaces part of the console. What do the route tables look like? Well, I mentioned that the public subnets will have a route to the internet gateway. That's pretty standard. We've actually put some NAT gateways into those public subnets. So as you might expect, the private subnets then have a next hop of default route that goes via those NAT gateways. But what about the route table I'm using for those connectivity subnets? Well, actually, I don't need to do anything with them. We've got just our default in there, the local entry that is always created in a route table. That's fine. We can just leave that alone for the moment. So at this point, we have our transit gateway attached to our VPC, and it's going to work in the way that we've already described. The thing just to consider is back on the private subnet here, I have added that route, the 10.8, via the transit gateway. So this is how we're going to establish connectivity from anything that is in the private subnets to the rest of our VPCs that are attached to the transit gateway. That's the only place that I've put 10.8. Okay, so this is where it gets interesting with the inbound routing side of things. What do I mean by that? Well, here's our VPC that's now pretty familiar to us. We've got the 3 network interfaces from the transit gateway, 1 per availability zone. And remember that route table that we looked at doesn't actually have to have anything in it. It's just got the local entry. We have a packet coming in. This is Dave again. He's coming in from the transit gateway. He's trying to get to the EC2 instance that was 10.1.0.50. Well, the entries in that route table tell him that that's local to the VPC, and of course, that's fine. So Dave is now quite happily over at that EC2 instance. He's got the 10/8 route back to the transit gateway, so that's how traffic will normally flow if you don't change anything else. But we can actually be a bit more creative here. So we can go back to the route table that is inside the transit gateway and statically add an entry to it. Now, in this case, I'm actually creating a default route. So I'm introducing a 0.0.0.0/0 route into the transit gateway route table. And what I've actually specified here is that if the traffic doesn't match any of the other more specific entries in that route table, send the traffic to the attachment red. So I'm sending it into my VPC. Now, I've simplified the VPC diagram a little bit here. I've just removed the other subnets in the other availability zones. But we now can see that that traffic is going to flow into this VPC. So what happens next? We're inside the VPC. We've got the route table that earlier didn't have any other entries in it. But actually, the traffic that's coming in from the transit gateway will obey that route table. So we can actually add an entry in there that says, if you receive a packet and it's not for this VPC, it's addressed to perhaps something out on the internet, let's just send that traffic to the NAT gateway. So now we have centralized our outbound internet access from all of the other attached VPCs to our transit gateway through this particular VPC. So that's the inbound routing capability that you have by modifying that route table. Now, the important thing to remember here is if we're sending that traffic out to the NAT gateway, remember in our route tables earlier when we looked at the public subnet, we didn't have an entry in there for the return path. So let's go back to thinking about Dave. If his packet gets out there, it gets translated, how does he get back? We just need to go and put an entry into the route table for those public subnets now that identifies 10/8 is available via the transit gateway. So this is all about next hop routing. This is that inbound traffic coming into our VPC. And if you're going to be using this, you do need to consider the fact that it will come in on one of those particular network interfaces. And you want to consider that you want to keep that traffic ideally within the same availability zone. So it's a concept that we call AZ independence. And therefore, you might actually choose to have a separate route table for each of those connectivity subnets, just to keep the traffic aligned to that particular availability zone. That would be our best practice recommendation. And therefore, that next hop would effectively be 1 per AZ. So let's go back to our VPC here. I've taken out the public subnets. This is now a VPC that doesn't have internet connectivity, doesn't have an internet gateway, but we still have our connection to the transit gateway. What if we want to use things like the newly announced Route 53 resolver service, the endpoints that you create for that? Well, what does Route 53 resolver do? It creates endpoints by putting an ENI into your subnets. What about if we look at VPC interface endpoints? Perhaps you're accessing some of the other AWS services via those endpoints. Again, what does it actually do? It creates a network interface that is inside the subnets inside your VPC. So these have an IP address that is within the CIDR range for that particular subnet. Private link is exactly the same. It creates a network interface inside your VPC, and again, another IP address from your range of IPs. Well, what does all of that mean? It means, well, where we have a connection to a transit gateway here, all of the other VPCs can actually access any of these endpoints. because they're just IP addresses within the 10.1 VPC. So again, you can see this gives you options perhaps to centralize connectivity to some of these other services and other endpoints that you might be using. But there's kind of an important thing to remember here. Whilst there is no specific configuration required from a routing perspective, you do need to step back and think about how are people actually accessing these endpoints. So they're probably using DNS. If you're calling some of our APIs, you're using our standard endpoints, where we have changed the endpoint IP address to now be inside that VPC. So you just need to consider that perhaps from your other VPCs, you need to do something with DNS. And Route 53 Resolver that we announced a couple of weeks ago actually is a really good way of doing this. So you can manipulate and control how traffic is routed from a DNS perspective and return particular entries for those services. So if you're going to be doing this, have a closer look at Route 53 Resolver. Now, I used the example there of a NAT gateway, so an AWS managed service for sending that traffic out to the internet. But obviously, you could actually do this with any EC2 instance inside your VPC. Some of you may already be doing this, routing your traffic perhaps through something from the marketplace that you've deployed to manage or monitor or control access out to the internet. Well, you can absolutely do the same thing here. But it's actually quite interesting that you might want to be able to route traffic through a middle box between two other attachments. So we'll come on to that in a little bit more detail in a minute. The important thing to remember is if you're going to be setting up a middle box type architecture here, you want to put the next hop, the EC2 instance, in a different subnet to the connectivity subnets I showed you earlier. So what does that actually look like? Well, here's the example here. We've got our route table. We're saying that this time the traffic is going via an ENI, so a marketplace instance that we've deployed in here. And the next hop is that ENI. Obviously, that instance is probably in a public subnet. But in this case, what we're actually considering is that we don't use this to get out to the internet. We want to use it as a path for traffic between two VPCs that are attached to our transit gateway. So think about what we can use that inbound routing for here. Here's our next hop. We've got that ENI to the middle box. But what if we actually look at the route table for the middle box subnet and send it back to the transit gateway? So this is where we can use that concept of having two route tables inside our transit gateway, one that is associated to the attachment. That determines traffic coming into the VPC, into the transit gateway. But for traffic leaving, we can actually put an entry in there. So we've got a default route here that says, send all traffic via this particular VPC. It comes in, it goes to the middle box, we can then send it back again. So that might be kind of interesting as well from an architecture perspective. Obviously, in this scenario, you still need to consider the AZ independence that I mentioned, so perhaps deploying multiple instances and aligning your traffic to those particular AZs. The other scenario, though, that you could do here is actually to use VPN connections. So you could host EC2 instances in another VPC, give them an elastic IP address, and build VPN connections back to the transit gateway. And that gives you some pretty creative options that Thomas is going to talk a little bit more about later on.
Thanks, Steve. So Steve did a great job of going from the 1,000-foot view to a 100-foot view. And so let's talk about what other capabilities that are available in the transit gateway. So we've talked about VPN attachments and how simple and easy that is to do on a transit gateway today. But one of the things that our customers have talked to us about is how do I get more than a gig of IPsec traffic bandwidth to AWS? And so when VPN connections are actually attached to a transit gateway supports equal cost multipathing. And so what does that allow you to do? So think of equal cost multipathing as a routing strategy where the next hop goes to a single destination, but there's multiple best paths, right? And so in this case, if we basically advertise the same IP prefix across all the VPN connections, transit gateway will distribute that traffic across all those connections. That allows you now to create elastic bandwidth across those VPN connections. And so why would I use that? So for example, a customer who may be using a 10 gig direct connect might want a backup. Previously, they would only have a 1 gig VPN connection. In this case, they could actually create an 8 VPN connections against a transit gateway and create equivalently a 10 gig pipe. The other thing that we started off with was transit gateway supports thousands of VPC connections. And so we know that we want to be able to support multiple accounts across all those connections. And so how do we do this? So transit gateway uses the newly announced Resource Access Manager to centrally manage resource sharing. And I think I hit the wrong button. Sorry about that. Yeah, resource sharing, sorry here. I think I had 2 slides too many. Apologies here. Okay. So how do you do that? Technical difficulties. So how do you do that? So it's really like a 3-step process. So you would start with the Resource Access Manager, where you would go in and create a new resource share that's centrally managed. The owner of the transit gateway would go in and create the resource share and the participants of who would actually access that. And that could be either accounts in your organization or accounts outside of your organization. Now, it's important to remember that those participants accept the invitation. So think of it as the transit gateway owner enables sharing. The next step is for the participant, in this case the VPC owner, to be able to request an attachment to the transit gateway. And when they request that attachment, because they were part of one of the principals as part of the resource share, they're now able to describe the transit gateway, they're able to attach to the transit gateway, as well as they're able to make those attachment requests. And the third step is the transit gateway owner now has the ability to accept or reject that attachment request. And so in this case, you can actually set it up as auto-accept, or you can manually accept those requests. And so why would I do that? Why would I actually do that? So think of it as the network teams want to be able to control the transit gateway, but they want to allow the application teams to be able to use network services. And those teams, when they use those network services, you want to be able to attach and describe, but you don't want to change your network configuration. And so what would that look like? So if we go to the console for the Resource Access Manager, all we have to do is put in a name for the resource share. We would basically select Transit Gateway as the resource that we want to share. And then under the principals, we would actually select or provide the accounts that we want to share. And those, again, could be within your organization, or they could be outside of your organization. And that's it. So we talked about how Transit Gateway is a fully managed service, and it works with all other AWS services as well. And we talked about how it connects with VPCs and VPNs. But with launch of the Transit Gateway, we actually support CloudFormation templates, which allows you to easily automate your build process. As well as being able to monitor the Transit Gateway, we integrate with Amazon's CloudWatch. And you have metrics on packets in, packets out, drop packets. You also can enable flow logs on your ENIs for all the VPCs that are attached to the Transit Gateway. As far as pricing, so there's 2 dimensions to pricing for the Transit Gateway. You're billed hourly for every attachment to the Transit Gateway, as well as for data processing, it's 1 for every gig that's processed by the Transit Gateway or to the Transit Gateway from each of the attachments. Region availability-wise, we are currently launched in 6 regions, and we have more coming by the end of the year. So we talked about how Transit Gateway is a highly scalable service. We wanted to make sure that whether your journey started with 2 VPCs or thousands of VPCs, that Transit Gateway could support that for you. And so the Transit Gateway, we're supporting up to 5,000 VPC attachments against the Transit Gateway, as well as you're able to install up to 10,000 routes on the Transit Gateway. And then as Steve mentioned, the power of the routing domains and being able to create these flexible network topologies, we're supporting up to 20 route tables. So what's on our roadmap? Now this is kind of dangerous when you actually put some stuff on the roadmap, right? So you can't hold me to it. So we know that Direct Connect is important for our customers. And so right now at launch, we're supporting AWS VPN. If you're a Direct Connect customer, if you're a public Direct Connect customer, you can actually connect to Transit Gateway using AWS VPN. For private Direct Connect, we're going to be providing that support in Q1 2019. This next one actually gets me excited. And so when we were designing Transit Gateway, one of the things we wanted to do was to be able to create a global network. And so it's not just about having a transit gateway within a region, but what if you can connect transit gateways across regions? So you have a transit gateway in your US East region, and you want to be able, all those VPCs in your US East region, you want to be able to send traffic to another transit gateway in, say, Asia Pacific. You can do that when this comes out. And so think about how you might be able to use that. So take an example where you have a branch office that's in Virginia that basically uses a VPN connection and connects into the US East region, sends traffic over to the Asia Pacific region, and then through a VPN connection, sends traffic down to an office in Mumbai. You just created a global network, all within AWS. And then additionally, we want to continue to provide advanced routing capabilities for our customers. And we were really excited about what you can do with routing domains. And if you think about that, in the ability with routing domains that Steve went through, what else can we do for our customers? And what we're looking to do is add the ability to do policy-based routing. So think about policy-based routing as being able to make routing decisions on the properties of a packet outside of just the destination IP. That's going to be powerful when you'll be able to do that. So to bring it all back home and back together is we talked about how in this journey, when we built Transit Gateway, we wanted to make it simpler and easier for customers to connect thousands of VPCs together. So no matter your journey from 2 to thousands, we want Transit Gateway to be that simplifying ability. We talked about how you want to share your edge connectivity. You don't want to have to make a network change every time you add a new VPC, and Transit Gateway allows you to do that. The visibility and control with Transit Gateway, now you have a central place where you can make all those routing policy changes. And where Steve was talking about middle boxes, think about that. You now have the ability to put other services and share those network services, where those network services are things like Active Directory. Those network services could be a firewall. Those network services could be other AWS services like Private Link or a NAT gateway or an NLB. All those things work through a Transit Gateway now, and you have one place to do that in. Feature interoperability, we talked about how Transit Gateway works with other AWS services, CloudWatch Metrics, CloudFormation, flow logs. And then for those customers who use VPN, the on-demand bandwidth and be able to ECMP traffic across multiple tunnels, there's many different use cases where you can use that, whether it's at a branch office or a backup for VPN or for a direct connect. And then with routing, we're excited to see what customers are going to do with the routing constructs that we have with routing domains and be able to use different types of next hop abilities that are there. Thank you.
So there are a couple of other sessions happening this week that I just wanted to draw your attention to, where there's going to be some mentions of Transit Gateway. First of all, we have Dave Brown, our VP for EC2 networking. He's doing a leadership session tomorrow afternoon. Definitely recommend you go along to that to hear about some of the cool things we've done with networking at AWS over the past year and some of our future plans. There's a session that Nick is doing on Thursday where he's going to be diving into those reference architectures, some of the ones I had on that list, and explaining how you can build those. And then finally, if VPN is your thing and you want more detail around VPN and our plans there, what we've built out and how that interacts with Transit Gateway, Tom is doing a session on Friday that I'd also highly recommend. So I hope you're all as excited as we are about Transit Gateway. We think it gives you a lot of new capabilities. We're looking forward to seeing what you do with it. So thank you very much for coming to the session, and we'd really appreciate your feedback in the mobile app.